Hello, my name is Ravindra Singh. In this video, I'm going to talk about STP attacks and mitigation. So as we have discussed about the STP, that STP basically used to avoid loop in a network. So as you can see in this scenario that we have two access layer switches over there. So the switch one is your root bridge, which has the priority 8192 with the MAC address 1234. Now what if there is an attacker sitting over here and it's trying to send a Bpdu message. Bpdu stands for Bridge Protocol Data Unit. So it is going to send a Bpdu packet with the lowest priority or the lowest MAC address, simply lowest bridge ID. So now what will happen? This attacker will become the root bridge. So whenever the attacker will become the root bridge, all the traffic will be forwarded through attacker. So how can we mitigate this problem? We can enable a Bpdu Guard on access port. Whenever we'll enable the Bpdu Guard on that port, so the switch, once it will receive a Bpdu packet, it will move to the error disable mode. So that's how we can mitigate this problem. Next one is port fast. So why do we need port fast? As we can see in this scenario, like we have a server sitting over here and also one client. So for example, this server is your DHCP server and this is your DHCP client. So what will happen when the client will come up, it will start to sending out discovery packets. But that port will not receive this discovery packet unless it will come to the forwarding mode. So it will take some time. So first the port will move to the listening, then learning, and then forwarding. So it will take some time. It will take 15 seconds for listening and 15 seconds for learning, and then it will come to the forwarding mode. So whenever it will come to the forwarding mode, it will start to sending off the user data. So now what we want, whenever the client and server is going to be up, the port should come up very quickly. So the feature is port fast. So by enabling the port fast, the switch port will come to the forwarding mode. Next one is the root guard. So root guard is saying root guard feature prevents a switch from becoming a root bridge on configured ports. Maybe you are coming with a switch who has the lowest priority and you are trying to connect this switch over here. So what will happen right now, as you can see that port, the switch is your root bridge for now. Whenever we'll find a new switch with the lowest priority or lowest bridge ID will become the root bridge. So whenever we will enable the root guard, it will prevent a switch from becoming a root bridge. So as we can see in this scenario, we have three switches. The first is distribution and these two are your access layer. So there are some, your devices are connected, which is your another block, maybe your server block or any other client block is connected over here. And also one attacker PC which is connected over there. So right now as we can see, switch 1 is the root bridge. So now I'm going to discuss about the port first. So let's go and verify the port. So spanning tree. So it's a gig 0/1. So right now it is in forwarding state and the role is designated. So let's see that how much time it's going to take to come up. So I'm going to configuration mode, interface gig 0/1. First I'm going to do shutdown and no shutdown. So let's see, right now it's showing the block, still block, 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 still block, learning. It will take approx 30 seconds to come to the forwarding mode. Now it's came to the forwarding state. Now what if you want to make this port to quickly come up? So what we can do, we will make this port fast. so that whenever the client will come up, the switch port will be on forwarding state very quickly. So let's go and configure the port fast. So port fast is only enabled on access mode. So first I'm going to configure switch port mode access, and the command is switch port, command is spanning tree port fast is, so this command saying the port fast should only be enabled on port connected to the single host. Connecting hub, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporarily bridging loop. Use with caution, and port fast has been configured on gig 0/1, but we will only have effect when the interface is in non-trunking mode. So right now it is in non-trunking mode. So now let's see and verify that how much time it's going to take to come up. I'm going to shut down this port and no shutdown. Now it's came to the forwarding quickly. Again shut down, no shutdown, and try to check. It came to the forwarding state. So that is how we can configure the port fast to reduce the time. So the next one I'm going to configure Bpdu Guard. So I'll configure the Bpdu Guard on gig 0/1. So it will stop receiving of Bpdu packets. So let's see that how many packets you have received on that port. So the command is show spanning tree detail. So here we can see in gig 0/1 we have not yet received any packet. Maybe if you are trying to receive, you sent 23 packets. If someone is sending Bpdu, because right now I'm not attaching any switch nor I'm trying to send any Bpdu, so received is 0. So if someone is trying to send any Bpdu and we have enabled the Bpdu guard over here, the port gig 0/1 will move to the error disable one. So let's go and configure let's first send few Bpdus. So I'm going to here action, execute an attack, STP, and I'm trying to send some Bpdus. Let's verify that how many Bpdus has received on that port. So for now you have received 296. Wow, 1624. So how can we stop these receiving of Bpdus? By using the Bpdu guard. So let's configure the Bpdu guard. Let me stop this attack. Bpdu guard enable. So whenever it will receive, it will detect any Bpdu packets, it will move to the block this Bpdu guard, receive Bpdu on gig 0/1, disabling port, and it will move to the error disable. We'll try to verify. So interface status, it's moved to the error disable. It has also the same two methods to recover this port. Either you can go manually inside the port, shut down, and no shutdown. It will come up. So spanning trees, right now it's in forwarding state because we have configured the port first. So for now receiving is 0. Still, if you try to send any Bpdus, it will again move to the error disable mode. It has detected a port Bpdu on this port. It will move to the error disable state again. So the first one, it was the manual one by going to the interface, shutdown or shutdown. Another one is automatic, which is by default disabled. So the command is error disable recovery cause Bpdu guard, enter. So by default the timer is 300 seconds. We can also change the timer. Interval 30. If you'll try to verify, so here we'll find that Bpdu Guard is enabled. Timer interval is that much seconds. So it was the earlier 300 seconds. That's why it's trying to count from the 300 seconds. It will take time. Or if you want, then you can go to the gig 0/1 shutdown and no shutdown. It will again move to the error disable, and in every 30 seconds it will try to recover the port. So as you can see, 17 seconds are left. 14, 12, 9, 7. Attempting to recover from Bpdu Guard error disabled state on this. Now port is up. So the next one, I'll show you that maybe someone is coming with a switch and trying to send lowest bridge ID and trying to become a root bridge. So how can we mitigate this problem? So we will enable the root guard. So let's see, and let's do the first attack, and let's verify something before doing the attack. So spanning tree. So right now gig 0/2, which is pointing to the root bridge. As you can see, the role is root port. So this port is pointing to the root bridge. Gig 0/2 means we have a root bridge which is switch 1. Let's assume that I'm going to add one more switch over here with the lowest bridge ID. So what will happen? Claiming root role. Earlier it was gig 0/2, now it should be gig 0/1. As you can see, gig 0/1 is the root port. So means whoever has the priority 1, but MAC address, this is the MAC address, it's trying to send a lowest MAC address for the root bridge. So let's go to the switch 1 and verify whether it is root bridge or not. So saying that gig 0/2, whoever is connected to gig 0/2, which is pointing to the root bridge. So right now switch 1 is no more root bridge. So how can we mitigate this problem? By using the root guard. So let me first stop this attack and go for the switch 3. Spanning tree, guard, root. So I have just enabled the root guard in the interface. So here you can see we have enabled the root guard as well as the port fast. So now I'm trying to send, let's verify. So spanning tree. So right now gig 0/2 is the root port which is pointing to here. So switch 1 is the root bridge for now. And let's execute the attack again. Execute an attack. Let's see what will happen. I have just executed the attack. You should get some error message on switch 3. As you can see, spanning tree, root guard blocking port gig 0/1 on VLAN. We will try to verify. So this is in a block port and gig 0/2 is still root port. So that's how we can mitigate this problem. Thank you for viewing.